Hello everyone, this is chapter 2 section 9 and we're solving inequalities in this one. So when you're solving inequalities, you can basically think of the inequality as an equal sign, right? So basically all the things we could do with equations, um, the properties of equality, like adding something to both sides and keeping the same equivalence, or subtracting from the same side, or multiplying from subtracting from both sides or multiplying from both sides. As long as we do the same thing to both sides, we'll keep the same equivalence um, of the inequalities, with one exception. Okay, and so it's pretty much just like equalities with just one exception, and then we'll talk about that in a little bit here. Okay, so first of all, this first set of directions is asking us to um, write the appropriate inequality symbol in the blank so that two inequalities are equivalent. So I'm trying to fill in this blank right here, right? So what inequality goes there? So if my original inequality is x plus 7 is greater than 0, so one way to do this is I can think of what number added to 7 is greater than 0, right? And there's actually a lot of numbers, like 1 plus 7 is greater than 0, 2 plus 7, 3 plus 7, 4 plus 7. We can go forever there, right? So any positive plus 7 is greater than 0. 0 plus 7 is also greater than 0, right? And even some negatives like negative 1, negative 2, negative 3. But where does that stop? That's right, at negative 7, right? So once you get to negative 7, it's no longer greater than 0. Negative 7 plus 7 is equal to 0, right? So, so basically anything greater than negative 7 is going to make this true, right? And so this and that are equivalent. Okay, so that's one way to do it. Another way to do it, if that was a little bit, if that didn't make sense, then you can, like I said, just treat it like an equal sign. So you can subtract 7 from both sides and just isolate x, right? So you get x on the left, the 7's cancel out, and then 0 minus 7 is negative 7, right? And you just bring the inequality down. Okay, so anyway, two ways to do it. So you can kind of think of it intuitively, or you can solve it like an equation. Okay, all right, let's try number 3. So if we're thinking intuitively, we want to think about 9 is less than or equal to 3 times what number, right? So what number can we put in there where 9 will be less than or equal to the product of 3 and some number, right? So anyway, so we can think of that. We know that 3 times 3 is 9, right? So anything less than 3 will make 9 greater than whatever that is, right? And so so we want numbers that are greater than 3 for W in order to make 9 less than that value, right? So greater than or equal to 3. Okay, so let's try to see how that works out. Let me erase some of this stuff for a second. So let's try to see how that works out. We know it's going to be 9 is greater than or equal to 3, but we can also find it by getting W by itself. Okay, and you might be wondering, well, isn't it supposed to be a less than or equal to symbol? And the answer is no, because remember the inequality, it always points to the smaller number, right? And it always opens to the larger number. Okay, so if 3 is a smaller number in this case, then it's got to point to 3, right? And if W is a larger number, then it's got to open to W. All right, so that's why it has to be greater than or equal to in this situation. Okay, so if you flip around an inequality, like an equation, you can flip it around and it's everything's the same, right? But when you flip around an inequality, you also have to flip around the inequality symbol. All right, number 7. So here we have negative 1/2 y is greater than or equal to 4, right? So for something to be greater than a positive, it would have to be a positive, right? So if we were multiplying a negative times y, what has to be true about y? has to be negative, right, in order to make that a positive. So, and what times a half would be equal to 4, right? If we're thinking about it as an equal sign, that's right, it would be 8. So we'd have to have negative 8. So if we multiply negative 8 times negative a half, we'd get positive 4, and that's greater than 4. Greater than or equal to 4. It's actually equal to, right? So, so what kind of numbers would we have to multiply to be greater than 4? That's right, negative 9, negative 10, negative 11, right? Because we want something that's negative multiplied by half, but we want them to keep getting absolute value-wise larger than 8 so that it can stay greater than or equal to 4, right? And so, so we want y to be less than or equal to negative 8, right? Because like if we plugged in negative 6 times negative a half is positive 3, and that's not greater than or equal to 4. So we need numbers that are less than or equal to negative 8, like negative 9, negative 10, negative 12, and so forth, okay? All right, so let's work it out algebraically and see if it checks out. So if I want to cancel this out and get y by itself, I'm going to multiply it by its reciprocal, right? And negative 2 over 1 is the same as negative 2, so I'm just going to multiply by negative 2 there. So here the 2's will cancel out, the negatives will turn to positive, and so I get y, and I'm just going to write this out for a second, but don't write it down just yet, okay? So I have y is greater than or equal to negative 8. But remember, we talked about earlier that we know it has to be less than or equal to, right? So the trick is whenever you divide or multiply both sides by a negative, okay? So whenever you have a negative that you're multiplying or dividing both sides by, you have to flip the inequality around backwards, okay? And so 4 times negative 2 is still negative 8, but we have a less than or equal to, okay? All right, so just remember that whenever you multiply or divide by a negative, and this is when you multiply or divide both sides, right? Both sides of an inequality by a negative, you must flip the inequality symbol. All right. Okay, keep that in mind. All right, so now we have some equations that we're solving, and then we're gonna put in interval notation and sketch the graph. All right, and we've done that stuff before, right? So, so now we're just a matter of solving. So we're gonna get w by itself. Okay, so I'm gonna add 1 to both sides. So I get negative 2 is less than w, right? Or in other words, w is greater than negative 2. So I'm going to put, so remember, when we have a less than without an or equal to, it's going to be an open circle, or we can use parentheses, right? Okay. And so, so I'm going to put a parenthesis on negative 2, and w is greater than, right? So it's going to go to the, the right. So w is greater than negative 2, so it's going to go all the way out there forever, okay? All right. So that's a solution on the graph. So now I just need to write the interval notation, which is going to kind of look like the graph. It's going to go negative 2 to infinity. And you always put parentheses around infinity, and then we already talked about why there's parentheses around the negative 2, right? Because it's just a less than without an equal to. So that's called non-inclusive, right? Or the endpoints are not included. All right, for number 15, if I want to get b by itself, I divide by 2. So divide both sides by 2. I get b greater than symbol. 8 divided by 2 is 4. So 4 is greater than b, or in other words, b is less than 4, right? So same thing as far as the parentheses go. Since it's a less, or since it's a greater than without an equal to, we're going to have parentheses. And so we're going to put parentheses around the 4, or on the 4 I should say, and we know it's going to the left this time because b is less than, right? B is a smaller number since it's pointing to it. Okay, and if we drew this in interval notation, we're going to have a 4 on this side, and then it goes all the way to negative infinity. And you always put parentheses around infinities, right?